Welcome grade 6 to your new lecture. Today we will start a new topic, unit number 9, elements, compounds and mixtures. In this chapter we will discuss atoms, elements, parts of atom, physical change, chemical change, molecules, compounds and their uses. Page 119. In this page, atom is described, that is, elements are made of atoms and each element contains only one kind of atom. So atoms are the smallest component of anything. They cannot be broken down into anything further. All of the things in our earth contains atoms. Page 119. What is an element? An element is a chemical substance that cannot be broken down into anything simpler. That is because it is made up of only one type of atom. For example, carbon is an element because it is made up of only carbon atoms. About 90 elements have been found in nature. The others have been created by scientists. These are some of the natural elements. Each name is followed by a chemical symbol, a kind of a chemical shorthand recognized all over the world. So element is a chemical substance which is made up of only one type of atom, so it cannot be broken down into anything simpler. Carbon is an element as it contains only one carbon atom, and in the formula we write C. There are total 120 elements, among of which there are only 90 elements that are natural. Others are made by scientists, and to represent each element we give them a chemical symbol, the shorthand. For example, sulfur is denoted by S, mercury with Hg, silver with Ag, and so on.
That atoms are the smallest invisible particles that make up everything.
Very good. Atoms are the smallest unit that retains the property of any element.
And they are so small that we need a microscope to see them.
The room you're sitting in, you, this screen, your clothes, are all made up of trillions and trillions of atoms. There are 118 types of atoms that make up everything around us.
So now let's talk about elements.
Okay, I am all ears.
Elements consist of only one type of atoms. Let's understand that with an example.
An element is a pure substance. In other words, an element cannot be broken down into a simpler substance by physical or chemical means. An element is made up of only one type of atom. Some common examples of elements would be carbon, oxygen, or iron. The elements are arranged on the periodic table based on their number of protons. For example, sodium has 11 protons. Potassium has 19. The number of protons of an element always stays the same. Each element also has its own unique set of properties.
Argon is an element found in nature as gas. This is an argon atom. Now many argon atoms roaming close to each other form argon gas or argon element.
Okay, so element argon consists of only one type of atoms.
This can contains rows of aluminium atoms. Aluminium is an element. An element is a simple single material that cannot be broken down into simpler material.
Atoms in an element are exactly the same.
Each element has a unique symbol consisting of one or two letters.
Like aluminium has a symbol Al.
Right. Do you remember the party we had last weekend?
Which? The barbecue party?
Yes, the charcoal that Mom used for the barbecue is made up of carbon atoms.
So carbon is also an element and its chemical symbol is C.
The symbol for each element is taken from the first letter or two letters of the common name of the element or its Latin or Greek names. For example, what do you think the symbols for hydrogen and helium are? Correct! H from the first letter of hydrogen and HE from the first two letters of helium. Now, let's try some that are a little harder. What do you think are the symbols for sodium, silver and gold? It can't be SS. How will we know the difference between both S's? It could be SO or SI instead, but that is not the case. Sodium, silver, and gold have their symbols based on their Latin names. So, it's Na for sodium, taken from the Latin name natrium. Ag for silver, taken from its Latin name argentum. And Au for gold, taken from its Latin name aurum. Don't worry, you'll get there. Keep in mind that when writing symbols, the first letter is always capital, whereas the second letter is small. 92 of the 118 elements that exist have been found around us in nature. We call these naturally occurring elements. The remaining 26 elements are created by scientists in their laboratories. These are known as man-made elements.
Next stage, page 121, metals and non-metals. Elements can be sorted into groups according to their properties. Are they dull or shiny? Are they liquid, solid, or a gas? Probably the simplest way of classifying elements is by dividing them into metals and non-metals. The main difference are in the table. Generally, we have two major groups of all the elements, that is metals and non-metals. Metals have their own properties, non-metals have their own properties. That is, metals are hard, heavy, shiny, malleable, and conductors of heat and electricity. Whereas non-metals are light, dull, they melt easily, they are brittle, they are poor conductors of heat and electricity. If you want to test metal or a non-metal, you simply have to make a common circuit, and in between them you have to add a crocodile's clip where you need to insert the material you want to test. The bulb is turned on, then that means the material is metal, otherwise it's a non-metal. Did you know carbon in the form of graphite can conduct electricity? It is the only form of carbon which conducts electricity.
We know that there are 118 elements in the world. These elements can be divided into two broad groups: metals and non-metals. About 70% of the elements are metals, while the remaining 30% are non-metals. Metallic elements share some similar properties, while non-metallic elements have their own set of properties. Let's take a closer look. To know which elements are metals and which are non-metals, we look at their physical properties. The first difference is, metals can reflect light very well. This is why they look shiny and lustrous. Non-metals, however, are dull. They are not very good at reflecting light. Another difference is that metals don't float in water generally, but non-metals do. This is because most metals are heavier than water, while most non-metals are lighter. Also because most non-metals are gases at room temperature like helium, hydrogen, oxygen. Few non-metals are solids like sulfur, phosphorus, and carbon. Metals, on the other hand, are mostly solids at room temperature. Some common examples are aluminium, silver, gold, and iron. This means they heat up very quickly as well as cool down very quickly when the heat source is blocked or moved away. On the other hand, non-metals take time to heat up and to cool down. Metals are really good conductors of electricity. Another reason metals are used for wires is because they are ductile. This means they can easily be stretched without breaking. Non-metals cannot be stretched. They are brittle, meaning they break easily. This also means they are not malleable, meaning they cannot be molded into different shapes without breaking or cracking, but metals can. Metals are also used in making cars, airplanes, or in factories for machinery because they have high melting points.
Next page, we have a uses of some elements. For example, liquid helium is used for cooling the magnet in medical scanners. Xenon is used in the headlights. Copper is used to make wires. Mercury is used in thermometer. Silicon is used in the computer hardwares or the silicon chips. And chromium is used in the cars.
Hi, this is Ben Finio with Science Buddies, and this video will show you how to use your basic circuits kit to determine if materials are electrical, conductors, or insulators. So here we have all the parts in the kit. You have 4 AA batteries. You have a 3 AA battery holder, so your kit comes with 1 extra battery. You have a small light bulb, a light bulb base, and 3 alligator clips, which get their name because they have these little metal jaws that can grab onto wires and circuit components. To assemble your kit, first you're going to put 3 batteries in the battery holder. Look closely at the batteries. You see that there are plus signs on one end of the batteries. There are also plus signs printed inside the battery holder. Make sure those plus signs line up. You can also check that the flat end of the battery is the side that goes up against the spring. So put 3 batteries in the battery holder, and then put the 4th battery aside. Next, just screw the light bulb into the base. And now you are ready to connect everything with the alligator clips. So we're going to color code here. Take the red alligator clip and connect it to the red wire from the battery pack. Take the black alligator clip and connect it to the black wire. And oops, you can see, so these alligator clips will hold on kind of snugly, but if you pull too hard, they will come off. So I lost the red one there. I'm going to reattach that. Now here's one important safety note. At this point, you want to make sure that the red and black alligator clips do not touch each other directly. That will create a short circuit and can cause your battery pack to get very hot. So keep those nice and spaced out away from each other on your table so they don't bump into each other. Now you're going to take your light bulb holder, and it has these 2 little screws on it on either side that you can connect to alligator clips to. Now it will be a little easier to connect to those if you actually take a small Phillips head screwdriver and loosen the screws slightly. That kind of gets the surface up away from the bottom so it's not flush there, and it'll be easier to get them with the alligator clips. So once you've loosened those a little bit, take the other end of the black alligator clip, connect it to one of the screws, and now take the green alligator clip, which you haven't used yet, and connect it to the other screws. So as of right now, we still have an open circuit. There is no complete path for the electricity to flow, so this light bulb does not light up. However, if I take the free ends of the red and green alligator clips and touch them together, I have a closed circuit, so electricity can flow in a loop through this red wire, through the green alligator clip, through the light bulb, and then back through the black alligator clip and wire to the battery pack. So check that your light bulb lights up when you touch these 2 alligator clips together. If it does not light up, make sure that all your connections are secure and you don't have a loose alligator clip, and you did not put a battery in the battery pack backwards. And once that's working, you are ready to start your experiment. Now, to test if a material is a conductor or an insulator, all you have to do is connect it to the free ends of your red and green alligator clips. I'm going to start out by testing this popsicle stick, so I take my 2 alligator clips and pinch them onto the ends, and notice that the light bulb does not light up. That means that this popsicle stick is an insulator. It does not allow electricity to flow. Now I'm going to remove my alligator clips and try with this quarter. Again, I'm going to connect to both sides of the quarter with the alligator clips, and notice that now that the light bulb lights up. This means that the quarter is a conductor, and it does let electricity flow in a complete circuit and through the light bulb. You can try this with all sorts of other materials and objects you can find around your house to classify whether they are conductors or insulators.